this is a web page for a class that I did. This is basically pre-metaphysics. And each of these links is a section of a 2-semester course. Not all of them are live yet because I never did finish all of this stuff. But the idea would be if I could sit in a quiet place and then do all those derivations or do all those example problems or do all those explanations of how things fit together, that would be kind of like the online textbook. And it would be a real lecture in the sense of it's a video of something rather than please go read something. And what this web page represented then was, let's see, well, here's a bunch of stuff on projectile motion. That's the typical starting point for a physics course because I'm a physicist, so I'm only going to talk about physics courses. But everything consisted of, a video. And these are none of them very long. I just want to find out where that one's 7 minutes, so I won't play it. But I'm sitting there with a little document camera and my pieces of paper and a Sharpie pen, and I'm going to do all the derivations that you would normally think about in a kinematic section of a physics class. And because I have the time and I'm not in a rush, I'm probably not going to make as many mistakes. In fact, I probably tell my students I usually make 50% of mistakes for every line that I write in a chalkboard, but here at least I can make sure I get it right. And I try to do all those derivations, and at least I have a repository of all the things that the students were complaining that I was not doing in the active engagement type class. And I tried to work into this set of web pages some example problems. So I even did videos with examples. That's actually an error reserve problem, which I won't go through, but I actually tried to reason my way through how to solve one of those conceptual problems that Eric Hazur did in his book. And I tried to make, literally, I took all the lecture notes I ever assembled for the class that I taught, and I made sure I did little video clips associated with every page of those lecture notes. And so it's a lot of little video clips. This is just a couple week section of the, or a 1 week section of the class. And there's probably 20 little video clips there. And then when I walk into the real class, I have the opportunity to fart around in a lot of other ways that I wouldn't have been able to do because I would have been so worried about making sure I got through all the derivations or sample problems that I knew I was supposed to do. But this is still a very flat model. It's a beaming out of information. There's no way for me to collect much from the students. And so what I came to learn about from some of the college folks is that there are better tools available for doing something like this. I will just say it's not unique to introductory level classes. I did it with a sophomore class, and I was able to write little videos on everything about how to derive a Schrödinger's equation and how to use it in solving problems and so on. So I don't think it's a model that's restricted to lower division classes because all the content is easier. I think we just have to think about what are all the things we would put in an upper division class and start piecing it into a lot smaller chunks so that we make sure that the students are aware of that this is a finite topic within even our upper division classes. I think that's still a reasonable model.
Sasha?
Yeah.
Once again, how do you use that right there? Is a student supposed to, do we expect the student has looked at all those things prior to your class so you don't cover that sort of stuff in your class? Or?
So yeah, my personal model, and again, this is not, I can profess that everyone should do this. I assigned typically 3 of those little video clips in a typical evening. And then because that was all the derivations and long form answer to things, I would start the class with a short quiz. And actually, I then later stopped doing that, and I did something that Mike Starberg taught me, which was he started every class with the students asking him 2 questions. I always thought that was a great idea. So they all wrote down on a piece of paper 2 questions, and that counted as a little quiz. And so I would collect all those questions, and I would try to shuffle them quickly in order to what I thought was going to be the right presentation for the day, but I would try to construct some answers to the questions on the fly, because I've lectured on this before, I sort of know how to do it. But I would at least go at some of the things that they were not able to understand based on these video clips. And then, because that would only take probably a half an hour in the class, I would try to end the class with, in my case, I this is an experimental field, so I would try to go through some key experiments in history that really exemplify the topic or give us our physical reasons that we know that that concept of wave-particle duality or something is true. And that, I felt like, again, that exploited my value added as an instructor, because I know something about experimental physics, and I know something about the foundations of quantum mechanics, and I can say a little bit why this is not just something printed in a textbook, but rather they're real live experiments that embody that idea.
Yeah. Are there any assessments built into the online or in class? Do you collect?
In this way of doing it, no, there really aren't. I did put some sample problems, and the students were free to go work them, but I had no way of collecting any of that information. So this is where I have to stop and say, okay, there's no feedback in this process, right? So, as you know well, Sada, because you were involved in the development of some of the things in Quest, as were Shane and John Gilbert and many others, John Markert, that kind of feedback can be really useful. So, the kinds of things that I wanted to learn to exploit myself, and I still consider myself a student of this process. I really can't say as I am an expert in any way, but I tried to take all of these things that I had been doing and embed them into Quest. And so my temporary euphoria, because we'll have to see how this really goes, but I'm very pleased that I can use some of that teaching model I've been wanting to do all this time and actually then build in the feedback and assessment. So this is literally the same introductory physics class. A few of us this summer were teaching an MCAT prep course, and Ruth was joining me in that suffering. I did my physics stuff this way, and I didn't really cover any of this in that MCAT prep course because I only had 6 days to do all the physics. So I made available to them all those lecture videos, and each of these things now or now go by the name of learning modules in Quest, but each of those video clips is tied to some assessment, and if I, as an instructor, wanted to, I could pull down the data of how successful were the students at mastering the assessments of that video clip. But for me personally, I was trying to build in that Eric Mazur model and try to do these conceptual questions first and then build up over the course of the learning module. So these learning modules, for those of you who have not seen them, let me just first of all say a little bit about what the architecture of a classroom in Quest now looks like. You as the instructor are able to generate a little syllabus like this, and so you can set up these kind of chapter headings for your class. If you have a 15-week class, these could each be the 15-week topics. I don't know how you want to do it, or maybe you'd say, I have a 15-week class and there are 5 major things that are important in your class. There might be 5 big bullets like this. However you want to do it. And then if we think of that as like an outline, that might be like my Roman numerals, I guess, and then my subheadings. Well, let's see, let's do kinematics, because I was showing you that before. There are prepared here 4 little learning modules in that particular Roman numeral, and it's ended with a homework. Okay, so that's the old-fashioned, I want the students to calculate a whole lot of stuff now. Okay, but all of this will be now in Quest. And so let's look at what a learning module looks like.